Hello friends, thank you for watching this video. I am Mohamad and today we're going to be discussing how we can implement MassTransit within our web API. We're going to be going through step by step of how we can actually implement an async approach between our services. We're going to be discussing a pub/sub model and why do we want to need it. And then once we covered all of the theory, we're going to be going through a step-by-step implementation with RabbitMQ. We're going to be installing RabbitMQ. We're going to be actually upgrading our services to take advantage of MassTransit and RabbitMQ. And we're going to be creating a couple of services so they will be able to communicate together asynchronously. If you like this video, please like, share and subscribe. It will really help the channel. As well, if you'd like to support me, please consider supporting me on Patreon or buying me a coffee. With that said, grab your cup of coffee and let's get started. So before we actually jump into the code and start implementing MassTransit, what we need to do is we need to understand the fundamentals. Why do we want to implement it? We want to understand the difference between a synchronous call and those asynchronous calls. So right now, what I have here is I have a very simple synchronous call. And what I have here is I have two services. I have a sender and I have a receiver. And service 1 and service 2 basically communicate together through HTTP. So the main layer of communication between these two services is going to be through REST. And we can see here that whenever service 1 wants to get any types of information from service 2, what do we need to do? We need to send a request. This request will basically be processed by service 2 and then we get back a response. And this is a very valid HTTP request scenario. But if we take a look at this, what's currently happening? Whenever service 1 is actually requesting information, service 1 is actually have the connection open to service 2 while we get back the response. So if service 2 is really well optimized, we can get back the response in basically 10 milliseconds. But if something goes wrong, or basically service 2 is relying on any types of third-party services and there's a lot of data call, this 10 milliseconds flies out of the window. So instead of having 10 milliseconds, we might have up to 1 second. And 1 second can go up to 10 seconds. 10 seconds can go up to 15 seconds, etc., etc. It all depends on how service 2 is actually processing the request, if there is any third-party reliance, if we're doing any types of retry, etc., etc. But what does this mean? Basically, it means that service 2 is actually busy trying to configure all of these other and processing those requests. And what also means is the similar amount of time and the similar amount of blocking of the resources is also happening within service 1, because basically service 1 has the connection open to service 2, and whenever the connection is open, it's going to have to wait until service 2 has finished. So basically it will happen something like this. So let me remove these. So right now, what's going to happen, whenever service 1 when I have to call service 2, a request will go in, it will go to service 2. Service 2 will take, let's say, 5 to 10 seconds. Now, service 1 have to wait all the way, or all of this amount of time. Service 2 will have to complete this. Let's say it took 10 seconds to complete. Once that's complete, it's going to send back the response to service 1. So here, basically, we have allocated the resources for these two services for 10 seconds. And this is basically one of the worst case scenario, but for the sake of argument here. And basically, once we have done that, we locked the resources, so we're not really able to get a lot of stuff more happening within service 1. Service 2 is basically controlling the flow of service 1 handling, because basically whenever service 2 finishes the job, it will need to send back to service 1 and to be able to process that request. And this is all valid for like a end-to-end or basically small HTTP request application, a small API, etc., etc. But if we want to scale all of this up, we're gonna have to face a lot of problems, because basically what we're doing here, let's bring those nice arrows back. Basically what we're doing here is we are actually hard locking these two together, because let's say for any reason service 2 is not working, service 1 whenever it sends the request, it will keep on retrying unless we implement some kind of a circuit breaker. If we, for example, if we want to retry after a few seconds, we're going to have to also implement this logic within service 1. So we're going to have a lot of overhead in order for us to build resiliency between these two services, in order for us, first of all, to assure smooth communication between these two, as well in order for us to make sure that whenever we are sending stuff from service 1, it will actually be received from service 2, and basically to be able to get it back. And we can see here that whenever we're gonna try to scale this out, we're gonna have to face a lot of problem. So that's the first scenario. So the second scenario, let's say I have to do requests with other services. So I'm gonna just remove this for now. and I'm gonna go back here. So now I'm only relying on service 2. But what happens if there's a new service that I wanna utilize? So that's gonna, let's say I'm gonna call this service 3. And another service, I'm gonna just call this, oops, we're not gonna go to that section yet. We're gonna go to another service, which is gonna be called service 4. Let's make this a bit higher. And here, what do I have? I have basically three services. So service 1 is gonna be the main initiator. And let's see what right now, let's connect these. So we're gonna connect this here, and we're gonna connect this here. So now it's pretty straightforward. I have every single request going to service 1 and to service 2, which is fair enough. But what happens if I want to actually scale this back? Scale this up, and I want to have to integrate with all of these different services. So it means that service 1 will also have to integrate with service 3, do some work. Service 3 will return back the response. Service 4 also. So again, from service 1, we're going to have a request going from service 1 all the way to service 4. And then from service 4, we're going to get back the response. So here we can see we have some kind of like a spider web, because basically right now service 1 have its resources directly allocated to all of these. So right now, let's say service 1 has a dedicated certain amount of CPU and RAM. So whenever we're trying to do all of these different calls, service 1 will have to handle the states for these 3 different services. Service 1 will basically need to manage those calls independently, and in case service 3 has failed, for example, service 1 will need to implement the logic for service 3, and then we need to implement the logic for service 4, although we are sending the same information across to all these different services in this example. So we can see here that there's a lot of repetitive and a lot of work that's going to happen in order for us to make sure that this is actually scalable enough, and this is actually can have not directly a point-to-point integration, or basically we are tying them point-to-point together. What we want to do is we want to make sure that service 1 is completely agnostic of service 2, and these requests gonna flow between them easily. So how can we solve that? So here what we need to do is we can actually utilize messages. And messages basically, in very simple term, is basically we send a request and we forgot about it. And basically whatever the other services need to do, they will do it by themselves. We don't really have to worry about how they work. So basically, in essence, whenever a service wants to send something to service 2, all it needs to do is just basically send it a message. And basically, once it sends the message, or it will move this message from service 1 to service 2, as soon as it leaves service 1 does not really care about it. As long as it knows that it's on its way to service 2, service 1 does not really have to worry about it. It does not have to wait for service 2 to get an acknowledgement, because for all it knows and all it cares about is that now service 1 is actually done its job, and it send that message. It's now the full problem of service 2 if it's not able to process it, if it's not able to read that message, etc., etc. But service 1 did its job and actually put the message correctly on the medium that's going to be sending it from one service to another. So this is called an asynchronous communication. And the asynchronous communication here, because basically we are decoupling these 2 services. We are not linking them together, because we're not really relying on service 1 to actually recognize service 2 response, and we're not really relying on these 2 knowing who each of these services are in order for them to work. What we're doing here is we're actually telling service 1 that if you need to send something, just put it on this transfer or any types of way we're actually to send messages, and service 2 will be able to know about it. So we can see here that we are completely decoupling these 2 services. On the other hand, within the first example, service 1 will have to know everything about service 2. We'll need to manage its connection. We'll need to manage if everything breaks. If there is any problems within the communication, service 1 will need to manage it. If service 2 is not able to process that request, service 1 will need to do a retry, etc., etc. Here, within an asynchronous approach, it's completely different, because basically as soon as the message has left service 1, service 2, it's its main responsibility, and we basically have decoupled. So right now, service 1 does not really know how to communicate with service 2. All it knows that it needs to send a message, and that's it. And we're going to be discussing about how we can actually send these messages and the way we're actually sending them. But for now, all we're going to be doing is we're going to be just exploring it on a very high level. We're going to be saying that To make this possible, we're going to be utilizing some kind of a medium to send the message. We're going to be delving into what is this medium in a bit. So this is basically a very simplistic asynchronous operation. But the main purpose or the main benefit that we're going to be getting is whenever we have a different receivers. So here we can see that I have one service and I have 3 different receivers. I'm going to call this, just for the sake of argument, service 3 and service 4. So here, for example, if I want to send a request between service 1 through different services, all I need to do is just send it one time, send one message, and basically this one message will be propagated to all of these different services that currently exist. And this is going to be the main power of this is going to be one of the main power of the asynchronous communication. Why? Because basically what I'm doing here is I'm just processing that message once and putting it on this medium, and this medium is basically taking the full ownership of how it's actually being sending this message to all of these different services, and every single one of these services is taking ownership about processing this message. So we're not waiting until service 2 is accepted this message and we're getting back an acknowledgement, and service 3 processes this message and we're sending back an acknowledgement, and then service 4, etc., etc. So we can see here that we are actually able to send one message, and we can have all these different services utilize it, and all these different services to process it. So that's all fine and good. So what is this called? What is this platform or this framework called? This is called a pub sub. Why is it called the pub sub? Because basically service 1 here is publishing, so that's going to be the main action. Service 1 is publishing a message, and basically these services are actually subscribing to a message. And what I mean by subscribing, here is basically they decided that they are interested in this types of message that service 1 is producing, and they want to listen to it. So for example, I can have here an additional service which is called service 5. And for any reason, service 5 is not really interested in processing this message. So service 5 will run, but it will not receive this message because it's not part of it. Let's say down the road, service 4 decided that it does not want to receive this message anymore. So that means that we remove the communication here, and service 4 will not receive this message. But this, if we decided that we don't really want to listen to this message anymore, we can see here that we didn't really change anything within service 1. We did not change anything within service, the medium that we're sending through. We did not. All we did is we changed service 4 in order for it to stop listening to this message. So here what we're doing is we're actually trying to implement a model where we actually publish a message to anyone who wants to hear it, and any service who wants to actually utilize it and receive it, they will be able to listen to it and get the information from that message. And this is going to be the main item here. We are publishing something, and basically we have different clients that you need, or basically different services that might need it, and whatever service has basically decided that it wants to get our information, they subscribe to it and they will be able to get this information to them. So here, let's say we want to upgrade service 5 to be able to listen to it. All we need to do is just upgrade the actual service 5 itself, rather than doing any changes to the service 1 or to the medium, and basically in that way we'll be able to get directly this information through it. So we can see here that the pub sub model, or publishing and subscribing model, allows us to send one single message to different types of services or different types of subscribers asynchronously and directly. So we don't really have to do a lot of the work, a lot of the integration over and over again in order for us to make that happen. So we can have 1, we can have 100, we can have 1,000, it doesn't really matter, as long as we have our services, service 1 publishing this message, all of the other services subscribing to it will get this message. And this is the power of asynchronous communication when it comes to services and microservices. What we're going to be building right now is we're going to be trying to create, currently we have one application which is called Formula 1 API, which has been updated to .NET 8. We're going to be having this Formula 1 API, we're going to be able to utilize it in order for us to send the message to another API, which is called the FIA API, and we're going to be building this communication between those two. So the first thing that we're going to be doing before we jump into the other section is we're going to be actually building this communication pathway, or this communication highway. And this communication highway here, we're going to be utilizing something called RabbitMQ. And RabbitMQ is basically, it's like a messaging platform, or you can think about it as a main information of highway, where basically all we need to do is put information there and we send it off, and whatever services actually subscribe to it, they will be able to listen, check on this highway, do you have the information that you need. In case you have the information that you need, they will be able to pick it up. And this is going to be the key thing here. So what we need to do is, first, before we do any of the work on any of those services, we're just going to create this path or this information highway to make sure that it's running for us. And once we have this information highway up and running, then we're going to be upgrading our services in order for us to take full advantage of this. And this is where MassTransit will come into place. MassTransit will allow us to implement all of this different functionality that we need in order for us to have this asynchronous communication between those different services. So I'm going to go back to Rider. So what I want to do right now is I want to add a Docker Compose file, and this Docker Compose file will basically gonna be my main way to create my infrastructure. It's gonna allow me to create this communication pathway, RabbitMQ, that I'm gonna be utilizing. So I'm just gonna right click on my solution. I'm gonna click add existing folder. Although the folder does not exist, I'm gonna create it, add a new folder. I'm gonna call it infrastructure. And inside of this, I'm gonna click on open. And now that I have my folder here, I'm gonna add a new file. I'm gonna call it docker-compose.yaml. Perfect. So now I have my docker.compose.yaml. We can see here it got the Y sign, which means it's a YAML file. And now what I want to do is I want to build this Docker Compose file, which is going to allow me to have my RabbitMQ up and running. So first of all, I'm going to make sure that Docker is running. And we can see that the whale icon started to appear here, and it means that Docker is actually picking up and started to run. So while this is actually running, let us start building those files. So first of all, I want to specify the version of the file, and this is going to be version 3.8. And then what I want to do is I want to specify the services. And then I'm going to specify that it's going to be RabbitMQ3. And then I want to specify here the container and the specific information for RabbitMQ. So first of all, I'm going to specify my container name, and it's going to be called RabbitMQ. Then I need to specify the image that I want to use, and this is going to be RabbitMQ 3.8 dash management Alpine. Perfect. So now that I have done this, I'm going to specify my environment variable. And within my environment, I need to set my password, and it's going to be rabbit_default_user. And this is going to be my username and password in order for me to authenticate with RabbitMQ. Again, for real life scenario, you'll not put it here, but this is the demo where we can actually experiment. And then I'm going to put RabbitMQ. Oops, I forgot the MQ here. _default_pass, and I'm gonna put here my pass. Pretty straightforward. So now that I have my environment ready, all I need to do is specify the ports that I'm gonna be utilizing, and I'm gonna have multiple ports. So the first one is gonna be the 5672. I'm gonna map this to the 5672. So basically this will allow me to communicate with the RabbitMQ as the pipeline that it is, and there's another one which is going to be the 15672, and this one is going to allow me to communicate with the UI front end of RabbitMQ. The other one is going to be mainly for the HTTP communication with the actual queue itself. So this is basically the main items that I need in order for me to have RabbitMQ up and ready. So I'm just gonna go to my console here, and what I want to do, let me clear this up. I'm gonna go back and I'm gonna go to my infrastructure, and inside my infrastructure, all I'm gonna do is I'm gonna put docker-compose up, and this should basically download the latest version of my Docker image, which is going to be the RabbitMQ Docker image, and then start building it for me so I can test it out. So let's give this a few seconds to run, and then we can see here it started to build my Docker image. And then once this is done, we can see it in action. It will take a few minutes.
A few moments later.
So now that it has run, as you can see here, I have my network infrastructure default ready. So this is the main network configuration that I need to have. And then I can see that my RabbitMQ container is created. So we can see here now everything is being set up, everything is running. Okay, perfect. So now that I know my RabbitMQ is 100% running, what I'm gonna do, I'm just gonna bring my Docker dashboard here, and I'm gonna bring it here. And if we scroll a bit down, I have a lot of stuff, but if I put here Rabbit, and if I open this, you can see here I have my RabbitMQ up and running. It has been running for the last 28 seconds, etc., etc. So that's exactly what I want. Now I can see here that my RabbitMQ is fully working locally on my machine. And now to test this out, I'm gonna go to my web browser, and inside my web browser here, I'm just gonna put localhost 15672. And here you can see that I have my RabbitMQ login. So I'm gonna get those credentials from my Docker Compose. So that's my username, and this is my password. And click on login. And once we log in, we're gonna be able to see that I have my RabbitMQ dashboard all available. Currently, there's nothing running. We can see everything is basically idle at the moment. Nothing is happening, nothing is running, and we can see everything is basically as it needs to be. So now what I did is, if we go back to my diagram here, what I did is I just made sure that this actual pipeline or layer of communication that exists between all of these different services up and running. Now this gonna allow me to go back to the main focus, which is gonna be creating the functionality inside my .NET services in order for me to be able to make sure that these two are communicating as they need to, and how I can take benefit of this communication layer, which is RabbitMQ with MassTransit, into my .NET Web APIs in order for them to be able to work. So, and I'm gonna just keep this running, but I'm gonna minimize it. And what I wanna do is, let me just create a new terminal. And I'm gonna go to my web API, so cd base app, cd to my Formula 1 API, and I'm just gonna do first .NET build. Again, this is running on .NET 8, so if you don't watch my video about upgrading .NET 8, I'll link it here somewhere. So once I have this here, the next step is I need to add some packages, so it's gonna be .NET add. Actually, let's clear this up so it's a bit clear. So it's gonna be .NET add package MassTransit. So this is gonna be the first one that I need to use. Perfect. Now I'm gonna put the other package, which is gonna be, let's clear this again. .NET add package MassTransit RabbitMQ. Okay, perfect. So now these are working. I'm just gonna minimize this. I'm gonna go to my CS Proj here. So I'm gonna click on edit CS Proj. And as you can see here that I have MassTransit installed, and I have also MassTransit.RabbitMQ installed. So perfect. So now that I have these two, the next step that I want to do is I want to actually start creating the message. So what we have done so far, I'm going to mark them by green so we know that it's being done. Oh, okay. So now this is done. What I want to do right now is I created this communication before using RabbitMQ. Now what I want to do is create this message structure. So whenever something happens within service 1, I'll send it to service 2, and then we're going to be upgrading. So next step is I'm going to create this message structure. So back to Rider. So if I open my Formula 1.entities, here, like you can see, I have my DB set and I have my DTOs. So what I want to add is I want to add a new folder or new directory. I'm going to call this contracts. And inside this contracts here, I'm going to add a new class, which is actually going to be a record. I'm just going to call this notification driver notification record. I can call it whatever I want. And I'm just gonna update this to reflect a record. So let me remove this, and here instead of it's gonna be public record, and this is gonna take basically a GUID, which is gonna be the driver ID, and it's gonna take also, let's say, another GUID, which is gonna be, actually let's make it as easy as string, and we can say it's gonna be driver name. So let's fix this. I think it needs to be capitalized. Oh, yes, let's make this capital. And basically the main idea of this message is whenever I create a new driver within my application, so whenever I create a driver inside my Formula One API, I'm gonna basically send a notification to the FIA saying that this driver now belongs to this team, something around those lines. So pretty straightforward implementation. So whenever a new driver is being created, this message that's gonna be sent is gonna contain, let's add a text box here, is gonna contain the driver ID and the team ID. And that's it. So once we do this, driver ID and the team ID will be inside this message. The FIA will receive them, and then it's gonna print it out in a log. So in the logs, we're gonna be able to see that this has been received. We can do whatever we want, but just for simplicity's sake, that's what we're gonna be doing. So whenever a driver has been added, we just send this information directly to the FIA app through RabbitMQ, through a message and all that, and then we're gonna be displaying it through the FIA application and the logs. So now that we have done this, the next step is I want to start building my service. So if we just take a look back one more time at this, so we have already created this communication layer. Let's make it green again. We have already created the structure. Let's make it green. Now what I need to do is I need to create a service here inside my Formula One API, which is going to be responsible for generating this message and actually sending it. So going back here, inside my Formula One.api, I'm just going to create a new directory, a new folder. I'm going to call this services. Usually what you do is you actually put these inside a different application. So you have a different dedicated class library, and this class library will mainly be responsible for handling this communication. For simplicity's sake, we're putting it inside the main project. If you're interested in seeing how you can actually structure it in a different class library, please let me know in the comments down below, and I'll make sure to cover it in a future video. So now that I have created here my services folder, I'm going to create another directory inside of it. I'm going to call it interfaces. And inside my interface, I'm going to create an actual interface, and I'm going to call this notification system. Actually, let's call it driver notification. I can have different types of notification. Driver notification, publisher service. Yeah, driver notification publisher service. Yeah, that should be fine. Let's add it here. And I'm going to change this from a class to an interface. And now basically I want to create the only method that currently exists, which is going to be send a notification. So it's going to be task send notification, and this notification will take a GUID for the driver ID, and it will take a string for the team name. Okay, perfect. So now that I have done this, now what I want to do, I'm just going to take this long name that I have, and I'm going to create a class inside my services folder. And perfect. I'm going to create this class, and I'm going to utilize or implement that interface, the driver notification service. Let's fix this reference. And now it's complaining I did not implement that method. Let's implement it now, and we can see here it's being implemented. Perfect. So now I'm going to put async here, and then I'm going to start implementing this method here. So the first thing that I need to do here is I need to initialize first a logger, which is going to allow me just to log everything which is coming through the service. The other one that I need to do is I need to actually initialize my RabbitMQ bus, or my MassTransit bus, which is going to be reliant on RabbitMQ. And this is really important because this is a service which is going to be communicating directly with RabbitMQ in order for them to send the message. So first of all, here I'm going to put private read only logger, and I'm going to take this long class name, and I'm just going to call this underscore logger, and then I'm going to put private read only ibus And this is going to be, as you can see in MassTransit, I'm going to call it _bus. And now what I want to do is I want to initialize these in a constructor, so I can just come here and initialize them both. So we can see both of them has been initialized through the constructor, which is good and nice. So now that, both of my services has been created, the logger and the bus service, and now I can utilize them inside my send notification. So I'm gonna start easily first by adding a logger.log information, and I'm gonna say here that notification, driver notification, I'm gonna just add the driver's name. So let me add here a $sign, and let me remove this. I'm gonna put here the driver ID, driver notification for driver ID is ready, just something like dumb like that. And lastly, what I want to do is I want to utilize the bus. I'm gonna put await underscore bus dot publish, and here I want to specify what types of information that I want to publish. I can put a new driver notification publishing, no, new, what did we call it? Notification record, new driver notification record. So that should be it. And the notification record will take the driver ID and it will take the team ID. Okay, perfect. So here what we have done is we utilized the bus in order for us to send the message. We have sent the message type, which the message type was the driver notification record. And basically this driver notification record here will take the driver ID and the team name, which is exactly what we want. So we have not configured the bus yet. We had not configured how to actually communicate with RabbitMQ. That will come next. The other item that we have here is the published, basically take a generic types of messages. And in this case, it took the driver notification record. The best way to implement this on a long run is to actually have a dedicated service which take a generic type of object, rather than here we have hard coding it into the driver notification record. And once you have this generic type object, you can actually just inject whatever object that you want and the publisher will send it. But again, for simplicity's sake, we're taking the easy route and we're just directly embedding it as it is here. So now that we have done this, next I'm gonna go to my program.cs and I'm just gonna inject this service here. So builder.services.add scoped, and this is gonna be my driver notification publisher service, and I'm gonna be driver notification publisher service. So that's gonna be my main service now. It's part of my DI container, so I'm able to utilize it inside my constructors, inside my controllers. And before I actually send it into start configuring my controller, what I want to do is I want to actually start configuring MassTransit here with RabbitMQ. So I'm going to put builder.services.add MassTransit, and then all I'm going to do here is I'm going to put my configuration, and it's going to be pretty straightforward. So I'm going to put conf, it needs to be conf, not cong, conf dot use, I think we need to add it, so using RabbitMQ, yes. And then here we'll have to take the context, so ctx, as well as the configuration again. And then we need to create this. Perfect. So now that I have told my MassTransit that I want to utilize RabbitMQ, is going to require my bus context and my bus configuration. So it's going to be pretty straightforward. So for the configuration, I'm going to be utilizing the host, and the host is going to be currently localhost. Again, depending on the environment, you might change it, but currently because we're locally, I'm going to specify the path. The vertical path is going to be like this. And then I'm going to now specify my different host configuration. So I'm just going to put it as H, and then I can specify the configuration for the host, which is host.username. We can make it as my username, which is we have added, and then we can put h.password, and this is going to be my password. Let's just double check it's the same. So my user and my pass, not my password. So let's update it here. So this implementation that we currently have here will basically directly configure our web API with MassTransit and RabbitMQ in order for us to be able to send messages there. And something that I did here, which is not recommended at all, but again, this is a demo, is first of all, I have hard-coded the host here to localhost. We should not do that. It needs to be coming from the app settings, as well as the user and the password are also hard-coded here, which is, again, should not be, should be here. They should be coming through a secret manager if you're using AWS, or for example Azure Key Vault if you're using Key Vault, or even like you are hiding them inside your local environment variable inside your machine. But again, for simplicity's sake, not to make this video like 3 hours long, we're doing it this way. We are able to directly hard code these value inside my program.cs, but this is not the way to do it in actually real life scenario. So now that we have actually configured this, and now we have MassTransit up and running inside my application, what I want to do is I want to go to my controllers, go to my driver's controller, and what I want to do here is I want to actually inject that service that I have created, which is going to be the iDriver notification publisher service, and I want to be able to utilize it. So I'm going to put here private read only iDriver notification publisher service. I'm just going to call it driver notification, and I'm going to inject this inside my constructor. So now I will be able to utilize it. So now this is here, and this is here. Perfect. Now I have it ready. And what I want to do is when I create a driver, which is going to be this one here, I'm just going to add it here. So I'm going to put await underscore driver notification dot send notification, and here is expecting the driver ID. So I'm just going to put result dot driver ID dot ID, and for simplicity's sake, the team, I'm just going to put Mercedes. Perfect. Actually, yeah, let's make it at Mercedes. Simple as that. So now that this is running, I'm just going to run my application. We can see it's building. And we can see we have problem. Let's see what the problem is. So the main problem that we're currently having is here. Because we are utilizing this in our program.cs as a scoped service, so basically it's a scoped within for every single request. What we're doing here is utilizing this in conjunction with the bus. It will create a problem because with the bus, it will create a problem because we cannot have both of them in scope at the same time. So what we need to do here, so we cannot have this scoped as well as utilize the iBus, because the iBus does not really work with it. If we're making it as transient, it will work, but just because we made it scope, let's see how we can actually implement this here. So what we need to do is we need to update this to utilize the following. So let me delete this. And it's going to be the I publish endpoint, and I'm just going to update this here. And instead of bus, I'm just going to put publish endpoint. Let me update this reference, here as well, and here I'm just going to put publish endpoint, and this should work. So that's the main issue. We should not have used bus. Apologies, it's my fault. We needed to utilize the iPublish endpoint here because it's a scoped call. So now if I run this, okay, and this is my problem. It's not the iDrive notification, it's the drive notification. So I put two interfaces here. So now if I run this, we can see it's running. So that typo cost me a bit of debugging time, but basically it should not have. I put I and the two interfaces that need an interface and the implementation. So now if I go back to my web browser and let's us run this application here. So I'm gonna go to localhost 5000, and we can see this is my application running on localhost. So for simplicity's sake, I'm just gonna have these two open one on one, and I wanna see that whenever I create now a new driver here, something will have to pop up here. So let's see how that will work. So I'm gonna go to post, try it out. First name is gonna be Mohamad. Last name is gonna be Lawand. Driver number, I'm gonna put 23, and I'm gonna keep this as is. Execute. execute, execute, execute. Okay, now I executed a few times. So now if I go back to RabbitMQ, we can see here that stuff has already started to happen. We can see messages started to come here. We can see that stuff is already on the queue. And if I click on connections, we can see that my connection is running. And if I go to my exchanges, we can see here that the stuff is being sent. On my queue is a driver notification record, which is exactly what I want and exactly what I need. And if I click on it here, we can see that this is the message that has been sent. And basically this is that I need currently, which is mean that everything that I currently have from the first part, if we go back here, it means that this application is now ready to send messages to the actual queue. So what we're doing here is we're actually generating this message. We're configuring it with my RabbitMQ and MassTransit, and I'm creating the message and putting it there. Now what I want to do is I want to create another API which is going to be responsible for picking up this message and actually displaying it. And this is going to be the exciting part. So let's see how we can actually do that. So going back to my rider here, tell you what, I'm going to keep this running. And what I want to do here is I want to create a new application. So under Formula One, I'm going to create a new project. And I'm going to choose here, it's called FIA.API. Web API, yes, .NET 8, no authentication currently, I don't really need Docker, so let's create this. And now you can see here I have my FIA API ready. So let us, because, okay, something else that we need to keep in mind, whenever you're creating a new .NET 8 application, as soon as you created the default implementation for it, it's gonna be a minimal API. So what I want to do is I want to delete this and I want to create it as a web API. So I'm going to delete this. Perfect. And I'm going to create this through my terminal, right? Because rather it's not fully supported of .NET 8 yet. So let's create it here. So if I type here ls, you can see this is my root directory. So let's create it here together. Okay, so in order for me to create it as a normal web API with controllers, I'm going to put .NET new web API, and this is going to be the main thing, dash controllers, then the name, which is going to be FIA.API. It's going to tell me that already exists, so I'm just going to force it. And now if I go here, add existing project, because basically it automatically changed everything there. I'm going to go to my CS Proj. And now if I open this up, you can see I have my controllers folder and it's a normal application rather than a minimal API one. Okay, perfect. So now that this is up and running, let us actually start by the configuration for it. So going back to my terminal, I need to install some packages, and it's going to be similar package I have done before. So I'm going to clear this up. I'm going to put .NET add package, and it's going to be MassTransit. Okay, sorry, I need to go to my FIA application and then add it here. Okay, perfect. Now let's clear this up. Again, I'm going to put .NET add package, and this is going to be MassTransit.RabbitMQ. Okay, great. And now the last item that I want to do is I want to add reference of my FIA API to my Formula 1.entity, so I can actually have the same record that my Formula 1 API is sending, which is straightforward. We're going to put .NET add, and here it's going to put FIA API / oh, we need to go one step backwards, cd, then I'm going to put .NET add FIA.API.CSProj reference to Formula 1 entities. Perfect. So now that all of this has been installed, let me go back to my FIA API. So cd FIA API, first of all, .NET build. So now that it has built successfully, what I need to do right now is, first of all, I want to configure MassTransit and RabbitMQ inside my application. So it's going to be here, and first of all, it's going to be builder.services.add MassTransit, and we're going to put first of all my configuration. Let's close this, and then here we're going to put first of all my configuration dot set kebab case formatter. That's what we want. Then we're going to put configuration dot set in memory Saiga repository provider. We set kebab case endpoint name formatter. That's going to be mainly for the formatting of the endpoint. But for the Saiga repository provider, if you're interested in learning about that, please let me know. I'll make sure to make a dedicated video to cover this. But for now, we're not going to be delving into it. And then what I want to do is I want to actually specify the assembly which is we're going to be listening to in order for us to actually process all of these requests. And basically what I want to do here is I want to create some kind of a service, and this service will be in an assembly, and that service within an assembly, I want to listen to it whenever my application start up to actually start listening to all of these incoming requests. So I'm just going to create a new variable called assembly, ASP, and it's just going to be of type of, we're going to put program.assembly. So basically we'll be able to listen directly to the DLL of my FIA API, look through it to find a service that's going to be connecting with MassTransit and RabbitMQ to listen to the assembly. Once I have that, we're going to put config dot add consumer, and this is basically the consumer that we're going to be listening to, which is going to be the assembly consumers. Then we're going to put configuration again dot add Saiga repository, actually Saiga state machine, and I'm going to put here just assembly ASP, and then we're going to put configuration dot add Saiga ASP again, we forgot the S, and lastly we're going to put configuration dot add activities, and we're going to utilize the assembly as well, and we're going to put finally config.use RabbitMQ, and we're going to take the same configuration that we have done here, so just we can avoid of time of retyping. I'm just going to take similar configuration as this one, so copy and add it here. Okay, perfect. And the last thing that I want to add before I close this here, I'm going to put configuration dot configure endpoints, and this is going to take the context. Okay, perfect. So now what I have here is I have created my configuration of the for MassTransit and RabbitMQ inside my new application. The last thing that I need to do is I need to create a service. So I'm going to create a folder called services. And inside the services, basically, I'm going to create the capabilities of me reading whatever information coming in the message and actually displaying it in the log. So all I'm going to do here is I'm going to create a new service to do this. I'm going to call it driver notification consumer. Perfect. I'm going to inherit from the consumer class interface, and I'm going to use here the driver notification record. So it's going to be the driver notification record, and then it's going to ask me to implement this. Perfectly easy. We're going to implement it here. So first of all, I'm just going to add a logger. So private read only logger driver notification consumer. I'm going to call it logger, and let's initialize this through the constructor. Okay, perfect. And all I'm gonna do here is pretty straightforward. I'm gonna put underscore logger dot log information, and I'm gonna put here FIA log so we can see it's the difference one. And I'm just gonna add context dot message dot driver ID, and I'm gonna add another one here saying team plus context dot message dot team. dot driver name. Oh, okay, driver name, not team. Okay, what did we do it here? Oh, driver notification record. We call the driver name. Okay. I think I sent the wrong thing, the other one. Okay, that's fine. Let me update it directly here. So instead of sending the team, I'm just gonna send the driver name. So I'm gonna put here result dot driver dot name, first name, and result dot last name dot last name. Okay, perfect. So now it makes more sense. Let me add the plus sign here. Yeah, now it adds way more sense. So now if I come back here, inside my service configuration, we'll be able to put the driver name, and the actual ID. Perfect. So now that I have this in place, I'm gonna put .NET run. .NET run. Now it's running, and we can see here it's actually listening to the local host of RabbitMQ. So what I want to do is I'm going to go back to my web browser. I'm going to make this smaller so we can see the logs popping up. And I'm going to come to my API. I'm going to create a couple of users, and we can see here I have an error. So let's see what's the error. Okay, this is the error. I did not remove this, and I forgot to return task.complete task. So now if we stop this and run this again, you can see here when you're just in a rush. So let's try to here again execute, and we can see here that my log is actually being received, and I can see my name and my FIA logs. The reason this says Mercedes, I need to stop my main application and run it again. So let's stop this and run it again. And now if I go back here and I click on execute, and if I click back to my console, we can see here that the name is changed. So now if I'm gonna put, instead of Mohamad Lawand, I'm just gonna put, let's say Donald Duck. Execute, and we can see here that Donald Duck is also saying showing, and it's working. The main item that we have seen here is basically we are able to send a message through MassTransit and RabbitMQ from one endpoint to another, and basically through one service to another directly to the messages. We are not waiting for a confirmation. All we have done is just put a message on the RabbitMQ using MassTransit, and we are able directly to receive it. So here what we have done is we have built a fully asynchronous application between two services, which is going to be my consumer and my producer, and we were able to send information through it. I hope this video was helpful. Please like, share, and subscribe if it was. If you'd like to support me, please consider supporting me on Patreon or buying me a coffee. And if you have any questions or anything not clear, please let me know, and I will make sure to cover it in a future video. Again, thank you very much for watching, and have a great day.